Okay, so we've talked about TLC plates, and we talked about how they're made, either glass or plastic backing most of the time, and there's a very thin layer of stationary phase that goes on top of that backing, and that stationary phase is either silica or alumina most of the time, but it doesn't have to be every single time that we use a plate. All right, so we need to go on now, and what do we do with the plate? Okay, so imagine that this is the microscope slide, or the TLC plate itself, and I'm looking at it now face forward. So here is basically the stationary phase that's been attached or adhered to the glass or the plastic backing. So the very first thing that I'm going to do as an analyst is I'm going to take a pencil. Yes, one of the first times you heard me say that. A pencil, and I mark the bottom of the TLC plate with the pencil. So I'm going to come up here about 1 centimeter, give or take a little bit, and I'm going to draw a very faint pencil line across the bottom. And the reason that I use a pencil is because ink is made up of dyes and pigments. And if I put this plate into mobile phase, then the dyes and the pigments will migrate. And I do not want that to happen because it contaminates my sample. So I only want to use pencil when I mark the TLC plate starting line. Okay? All right, so another thing that I typically like to do for me is I draw kind of a spot here in the center, and that will allow me to kind of go and put a dab of my sample onto that spot, and then I'm supposed to let that dry, and then I repeat that process again. But at least it gives me a point of origin, something that I know where I at least marked before my sample had dried, because once it dries, it's kind of hard to see. It just kind of blends in with the stationary phase, and you can't really see where you actually put your spot in the first place. So I typically draw a little circle right there in the middle, and that way I know that that is where I should spot my sample when I begin to analyze it. Okay, so the reason that you do this 1 centimeter from the bottom here is because this plate will eventually be submerged in mobile phase. And if you mark down here at the very bottom, and this is where you spot your sample, what will happen is that the mobile phase, let's say this is my mobile phase layer, will actually take that spot and it will dissolve it into the mobile phase itself. So it leaches out, and you do not want that to happen, right? You want the mobile phase to actually be sucked up the plate. And in order to do that, you need to make sure that your sample is above the mobile phase line when you put it into your container. So that's why we always go up about 1 centimeter from the bottom, and this is my starting line. My point of origin is what I would call that, and the reason is to prevent that sample from leaching out into the mobile phase and basically getting diluted in the mobile phase itself. We want this sample to be pushed up, and if this sample is below the mobile phase line, it will actually leach out of the plate instead of move up the plate, and we don't want that to happen. Okay, so 1 centimeter, give or take a little bit, from the bottom, I'll draw this point of origin or the starting line, and I'll typically draw a little circle in the middle to let me know where to spot my sample. Okay, so that's kind of the first thing that I would do when I would get a TLC plate and when I prepare it to put my sample on. I just want to make sure that I hold it by the sides. I want to make sure I take a pencil, draw the line at the bottom, draw a circle in the middle, a really tiny one, to tell me where to spot my sample, and then I'm ready to go. So in order to spot the sample, number one, you're going to use a capillary tube, okay? The capillary tube needs to be open on both ends. The reason is because most of the time this bottom open end will go into my sample that I'm trying to spot, and the top part, that's going to be maybe a finger. I'm going to put my finger on so that way I can put my capillary tube into the sample, put my finger on top, lift the capillary tube out, and my sample will be sucked up into that capillary tube, so I can just simply put a spot of that sample onto my TLC plate. Think of it as kind of putting your finger on a straw, right? If you are putting your finger on a straw in a drink or in a soda and you pull the straw out, the soda will be trapped into that straw and it's not going to leak out on you. But as soon as you release your finger, then all of a sudden that liquid is going to come pouring out. The same kind of concept's happening here with the capillary tube. I'm putting the capillary tube in the sample, I'm putting my finger on it, so that way I can create that suction, and then I can transfer that capillary tube over to my TLC plate and put my sample on the TLC plate in that manner. So that's really kind of the process of loading the sample up on the plate itself. So I'm going to take the capillary tube, I bring it over to the plate, and then I put one drop, that's really it, one drop on that spot and allow it to dry. So capillary tube number 2, you place one spot onto your plate, and number 3, you allow that to dry. Once it dries, number 4, I'm going to say repeat it. Now, sometimes that might be too much, but we don't really know in the beginning because it's kind of a trial and error type of situation. So we repeat it, and then if it is too much, it's no big deal. I just get another TLC plate and I just put less on it the next time around. But once I repeat it, that's typically enough. So it just really takes a couple of drops here of your solution in order for the TLC to work the right way. That's really what this is all about. So do not overload the TLC plate. So ideally, what we want to see is that once my sample goes onto the plate and it travels up, I should see a spot that shows up on the plate. If I have a plate and that plate has been developed, and instead of a spot, what I see is a smudge that looks like this, then that means there's way too much. So I would develop that plate again. I would take another plate, I would trash it. I would take another plate, get my capillary tube, put one spot, allow it to dry, and then I do not repeat it for a second time because this is letting me know there's way too much on there. So one of the ways that we can fix this problem is not put as much sample on it next time. So I'm going to put that as number 1. Put less amount. The other way that we can fix this is lower the concentration of the sample. If I lower the concentration of the sample, I put really ideally less of the molecule onto the TLC plate, and maybe it doesn't smudge anymore, but maybe it will stay as a spot like a TLC plate should look like. So that's going to be a common problem that you might experience in a laboratory, is the smearing effect that will take place. And that is due to typically too much stuff on the plate itself, and there's 2 ways to fix it. Don't inject as much next time, or number 2, weaken the sample down and then inject the same amount. And that typically can fix this smearing problem that begins to happen. All right, so that's kind of the proper way that we would load a TLC plate with sample. And then from this point, we then take it into what we call a chamber. And that's what we'll talk about in the next video.